He said the first three are Poisson from the Sammy stats problems.
Correct.
Okay.
And I went over some of them, right?
Yeah.
And you know, I omitted some of them as well that are like really different, you know, like misleading, whatever.
Number 6, I think.
Whatever one it was, I can't remember. Yeah.
Oh.
Ooh, good catch. Did you catch it?
Yeah.
Yeah, I didn't put number 6 on the test. Some of them are just like, oh, that's it, boom. Oh, that's it, boom. Okay. Nothing mind-boggling. Okay. Yeah, everybody's here. Mr. Barden is in the back. Okay. So that's what essentially the quiz is going to be about, and it's not that bad. If you guys want to work or whatever, that's not a big deal. But I know I'm a big movie buff and everything else, and who wants to know about insider trading? Me too. Yeah, yeah. I almost got my Series 6. Yeah. Could you get the light, please? Oh, let's look here.
It's about butternut squash.
Oh, that guy, huh?
Yeah.
I was gonna. Okay. I read that one last night. Butternut squash. Okay. So, why don't you read it for me, please? Go
So,
ahead.
when a butternut squash seed is sown, the probability that it will germinate is 0.86, independently of any other seeds. A market gardener sows 250 of these seeds. Use a suitable approximation to find the probability that more than 210 germinate.
Okay. Yeah, this one was the pain in the neck for me. Okay. So the first thing, what's the 0.86 represent?
The probability that it will germinate.
Germinate, right?
Yeah.
So we got to find I or something, right? Or is it I or double I? Or it's just one I? I can't remember.
It's just one problem.
Right.
Yeah.
So the first thing is that what they do is they multiply, which is called, they consider this not the mean, and they multiply. I call it n. So the first thing they do is they go UP.
Is this Poisson?
No, just a straight normal distribution. 0.86 times 250, and they get 250. That's the first step, okay? Okay so far? Yeah, probability times the mean gives us the expected value. That's what really that they're doing. I haven't talked about expected value yet, and I want to derive all this stuff. Okay. So you get 250. Now, the next question says, what is it? What do they want now? The probability of what?
The probability that more than 210 will germinate.
Classic normal distribution, right? So, here we go. What goes where?
See, x minus mu over sigma.
Yeah, okay, beautiful.
But don't you have to do the x?
So this is 215, yeah. And what's this going to be?
210.
More than 210, right? So what do we pick as a value? Yeah, you can do 211, but what they do instead is they like to do the half things, okay?
Yeah.
That's why I didn't like it.
Always do it in the middle.
Yeah, always in the middle.
You split it in half.
Right, so you go to what?
209.5.
I did, right, they only did one though because it was more. Right?
10.
Because to me, when I read this, especially when I used to teach college and stats, why not, Ryan? Why did you do 210.000000001? But then it's so significant. Yes, sir.
So you can plug in information in that formula even though x is greater than something.
Yes.
And that still works.
That's correct.
So if it was x is less than 210, then what would it look like then?
If X is less than
Well, yeah.
209.5. Yes, okay. That's all right. That's a good question. All right. So I'm missing something here now, right? I need sigma.
Yeah.
So how do I get sigma?
You have to solve for it.
Yeah, okay. I heard it. What? I thought I heard it. Yeah, no, yes.
Well, for the 0.86, can't you find a corresponding z-score, plug that into the formula,
Yes.
have the sigma, and then solve for sigma?
But they did sigma. They found out the variance for this one. And I didn't talk enough about variance. You could do that as well, right? And I think variance, this one would be, it's three things here, okay? NP, I call it NPU, but they call it, what?
NPQ?
Is it NPQ?
Yeah.
Okay, so what they did is they went, they put the U here, okay? So I'll put U here as well. And that to me is my N. And then this is P, and that's Q, okay? Is that okay so far? Mm-hmm. So here we go, right? 250. Now, you already know P and Q, right? Because one of them, it doesn't matter the order because you're multiplying, right?
It's 0.86.
0.86.
And 0.14.
And what's the 0.14 represent?
Yes.
Minus
The fail.
Right.
Yeah, the fail, right? That it doesn't germinate. Yeah, I thought that there was a lot of misleading things here, so that's why. But you get the idea. So sigma squared, which is the variance, is equal to 30.1.
And then we take the square root of that.
There you go. square root of the variance, which is 30.1. Okay, that was the hard part. Now I'm missing something, right? Because this is what? Greater than 1 minus this stuff, right?
1 minus. Oh, because
right.
that's going to give us the less than?
Yeah, that'll give you the whatever it is. I think
Yeah,
that's
so you
yeah.
say 1 minus.
And remember, you get some value here, and then you look it up on the table. So you're going to get some number here, right? You're going to get 1 minus 5. Remember 5 means you look, I'll put Z, is that okay? I'll put Z. That means just, hey, look it up on the table. So you get some number here, right? Whatever this number is.
So, yeah, we
Yeah, you're
find out
going
what
to get 0.82. And you go 1 minus, then you look up the probability here. And whatever that is.
which is the corresponding z-score for...
Correct, yes. Which is the probability, right? Whatever that number is. And I heard it?
Is it 0.7?
0.739?
0.7939.
See, 0.82 is the z-score, and we need
Yeah.
to find the corresponding probability.
Yeah.
So,
And you guys told me what this, whatever it was. What was it again?
0.7939.
And then this is 0 point, whatever it is.
yeah, something.
Okay? Whatever that is. Okay? And it's on number 16 here, too. Now, they just said points, what I don't get, right, Brian. What I don't get is they got 0.7939, 0.794, and then they said that was the answer. But
They
then
didn't-
why were they subtracting 1 from it then? That's my question.
Well, they didn't.
Because it's greater than, and our chart is only positive.
That's why. All right. So, and
But-
then that's the answer. Because correct region is greater than 1/2.
Wait, so is it's not the 1 minus thing, or did we do?
No, it is 1. If you look on the answer here, they do 1 minus.
But then they don't do anything with it.
But then they don't do anything with it, which makes
Right.
no sense to me.
That whole above the z-scores and whatever, that equals 0.82?
Yeah.
Okay.
Remember, this says, hey, I got inside the table, give me the Z. Okay? That's what it means. All right, Brian.
Okay, so I'm currently confused if it gives you
Yeah.
each thing is independent, a set number of trials and a success or failure.
Mhm.
Why is it not a binomial problem?
Because it didn't say exactly 5, it didn't say exactly 7 or whatever.
Yeah, but how
That's
do you-
one reason why.
So it's set up like a binomial distribution problem though.
Oh,
So-
because of P and Q, right? Because of
Yeah.
success and failure.
and the number of trials. So suitable approximation to find probability of more than 210. How do you transfer that to, I guess, a normal distribution?
Well, imagine if it was 210, right? How many would you have? Right? I mean, it would be 210. What would be your combinatorics then?
You'd have to do the choose 40 times over.
I mean, you would be going forever there, right? I mean,
Yeah, if you're binomial, you'd have to add up 211, 212, 213, and go forever. So
Yeah.
how do you do the approximation?
Normal
I know you
distribution?
just
you
split it.
right. I think because the number is so large, that's the reason why you use normal distribution.
I
How
thought
do
that
you-
when we needed to get an approximate, we used Poisson.
Yeah, okay. So
Yeah.
Poisson is when the average is really, I mean, when the values are small.
That's
right.
right. The 210.5.
Are you asking for the random variable why we choose 210.5, or are you asking
No,
for why we
I'm
use Poisson versus normal? Or
overall, the entire thing, it sets it up like a binomial. So it could have asked find probability exactly 210 Germany or
Yeah.
yeah, right.
it could have.
So,
It could have,
but
but
then
it
it
would.
asks
Yeah.
suitable approximation to find probability of more than 210. So that's 210 up to 250 Germany, right?
Yeah, you'd be there forever doing it that way.
Yeah. So how did you do that? How did you get that problem there?
Because they gave me the mean, and then the biggest thing is they gave me the mean, and the numbers were small. That's the only
Where's
reason
the
why.
mean?
They didn't give you the mean.
Well, they gave me the n. They gave me
numbers
n,
to find the mean.
and then I had to find the mean. But here, if you look on the sheet, they say the 250 is the mean.
How did you find the mean?
250 times 0.86, which is 215.
250 times 0.86.
Because that's the ones that
Yeah,
averagely germinate, right?
0.86 is the.
Yeah, this would be the mean. This should be, they labeled this wrong. This should be n, and then, right, and then you multiply by 0.86, right? So
Okay.
NP, I was right. The mean is number of choices times the probability, right? Number of trials times the probability
Yeah.
of
So
those
you can
trials.
turn a binomial into a normal distribution. doing that?
For here, no, you don't have to, okay? I know that once you get the normal distribution, right, they take that stuff, and then the second double I is then they turn it into a binomial. That's what they like to do. And you're going to see that like in a few problems. Now, like for numbers, I think it's number 14 or something, they do exactly what you said. So they figure out the success rate and then the failure rate. That's what you did here, right? Success and failure. So you see, maybe you saw this, I'm like, well, I can use the binomial, right? But the only question I would say, Ryan, is, okay, did it say exactly 4 choices, exactly 7, or more than 6? You see what I mean? Because your combinatorics would be just through the roof to do it. So there's no way you would be able, even on a Cambridge Superman stuff, that they would do it there. Hello? Yes, sir.
So when it says, like, for example, like more than something and it's going to be an astronomical number, don't use binomial and use an approximation for normal.
Yes.
Okay.
Yes.
Okay,
So,
so you
right.
get the mean and the standard deviation by doing that.
Yes. So go ahead.
So the variance is
Just the square of the
and yeah.
standard deviation.
Yeah, so the variance is NPQ.
Yeah. So I could have wrote this, right? X minus what? Mu
Yeah, it's
over the square root of sigma squared, right?
Yep.
Now, guys, we didn't talk about this, which I'm surprised. Square root of n over, what is it?
That's underneath binomial.
N over q? Something like that? Yeah. There's another one that's like this, but they didn't talk about it. Oh, I'm going to take that thing. I always want to grab this. This one's mine.
Do we have to know how to do the N over Q?
No. That's why I didn't choose this one. I was really favoring the butternut squash one, and I looked at it like, well, why wouldn't you do binomial, right? Because you got success and failure. And the only logical thing I could come up with, other than Cambridge being insane, is I see 250, 210, and so on. How am I going to get the combinatorics to do it? You know, the n choose r, right? That's just through the roof. I mean, it would be 210, 211, and so on. I mean, no way. You'd be there forever, okay? Even if it was 210, 0, 210, 1, 210, 2, I mean, there's no way you could do it. And I'm pretty fair. I usually say, you know, use the binomial distribution, ciao. See you later, man. Or I'll say that. I try to lead you to it.
So, like, what's the, like, when we use the Poisson, like, what would be, like, the differences in the types of problem?
Differences in the type of problem would be something to the effect of where it gives you a rate, and then lambda, I always say this, okay? Sometimes they give you lambda, and sometimes you got to figure out lambda, right?
Where
Yeah.
you Poisson on right now?
Evil Poisson on the thing here?
Yeah, sure. I don't know what.
On the thing here, let's see. They don't do Poissons on this one. So I did Poissons on my sheet.
Yeah.
Yes. That's the homegrown Sandy version, right? So Poissons are straightforward, okay? They're really straightforward. Okay, so
I have.
Which packet is it?
yeah, and I gave you 1,000 back.
Sammy selected stats problems.
Okay.
Yes, yeah, that's right.
The one that's the non-Cambridge one.
Non-Cambridge, we'll call it the non-Cambridge segment, okay? Remember I did the ESP one? That was a pretty good one, right?
Yeah.
That was not bad, right? And then I also did did I do the balls drawn from the deck here, number 3? I did ESP, I did the ball one, right? And I did the first 2. So I did 1, 2, 3, 4, right? Or wheat.
Yeah.
Wheat. I said go away number 5. I fell in love with 5 at 3 in the morning, I threw it away. And then we did like the airplane one about the crashes.
Yeah.
Okay, so how would you know which one to use other than saying it, right? Well, first of all, the average is somewhat like small. That's for 1, okay? That's a big thing. Or if they didn't give you the average, the lambda, then you figure out the lambda, the average. No difference. See it right here? Well, it's the same thing right here too, right? You'd have to figure it out. Yes?
Or if they don't give you enough information, like they don't give a probability, or they just give you like a mean or like some number, then you know that that's the big Poisson.
Yeah, they all for this one they gave you like, to me, I was like, well, what does this represent? I thought, when I first read it, I thought it was the random variable. That's what I said. And I did it, I tried to do it straight, without, but, and then I'm like, wait a minute, it can't be that way. So, 7, I talked about the birthdays. Did I do birthdays? No. And then they said out of 80,000 people, right?
Yeah.
I did that one. And then this one, I mean, they're pretty straightforward because usually your lambda is somewhat small. That's one thing. And it's over an interval of time. That's two big categories to do Poisson, okay? Or if you're finding like errors, okay? That's another one. I mean, I had another one here, but like, and I did lottery tickets, right? And then did I do the bets at all or no? Consider the roulette wheel. I might do that in the other class.
I don't think we did.
Yeah, that was a longer one. I didn't get a chance to do. Well, no, the roulette wheel is not that bad. 10's a little long, but not bad. But number 11 is straightforward, okay? Because look, it gives you. I know it says Poisson there, but if it didn't say there, an interval. If it says an interval of time, boom, you know
Poisson.
right away it's
Read
Poisson.
it out right now.
Which one would you like?
No, number 11.
9 and 11, or just you want to? It doesn't matter which one. 11 it is. Okay. That's a good question. Okay, all right. It's a good question. Wish I could answer it better. I think flim-flam. Okay, so we're doing number 9, you said, right? And it's on Sammy, right? Sammy selected for Poisson.
Yeah.
So you have roulette wheel, right? 38 numbers. And then, 1 through 36 and 0 and the double 0.
This is 9.
Am I doing 9?
Or is this 11?
I'm sorry. I'll do it. Thank you. Keep me honest. Oh, this one's hit. That's not. The web hits?
Yeah.
Okay. I know it says, if you just took Poisson on, you saw the time interval, right away it's Poisson. Right away. Nothing else you can do about it, right? So it says, okay, it says 5 hits per second, right? So 5 hits per second. All right, that looks pretty good.
Yeah.
And it says, for A, right? It says, what's the probability there will be no hits in 2 seconds? So far, so good?
So 0 is the X.
X is 0. He's 100% right. That's what we're trying to find out, right? Now, Ryan, you could absolutely do this by what? Binomial. You can. But the reason why they do Poisson is because you get the number faster and easier using the E, okay? Euler's constant. So, it said in 2 seconds.
10.
Right, okay? So lambda is equal to NP is equal to 5 times 2, which is 10. That's what we're trying to find, right? So far, so good? And now, just like Mr. Rupper said, we just go e to the what now? Negative 10. And then what? 10 to the?
10 to the X power 0.
Zippo over 0
Zero factorial.
factorial. And everybody knows 0 factorial now is?
1.
1. Everybody know why. Okay. So 1, just e to the minus 10, right?
Yeah.
Whatever that is. Okay? Pretty good?
Mr. Murmer?
Yes, sir.
Oh, wait, yeah, so we got part B. Let's do that.
Did I do A? Yeah, let's do B. Okay?
Yep.
B. This one is not bad, right? So it says me, right?
At least one hit once.
So X is what here? 1. Right?
Lambda is
At least 1 second. P.
Yeah.
Yeah? So it's going to be 1 minus what?
1 minus.
Right? Yes?
Yeah.
I'm okay? Say yes. Okay.
The screaming wasn't
Oh.
It was, we held a Cambridge test a month after graduation.
Exactly,
Okay.
1 month
So-
after we graduated.
Seriously?
Yes.
Oh,
Wait.
Lord help me. Okay?
Sorry.
Yeah.
It's not you.
Listen,
Sorry.
if I
That's
know
a
I passed
schedule.
the test, I'm not.
The estimated date for that last test is June 18th.
I'll put a thing there. E to what power?
negative 5.
Negative 5. Why is it negative 5? You're right.
Goes back to 1 second.
Yeah, 1 second, I told you the rate, right? Yeah, negative 5. And then what? 5 to the 0. And again, 0 factorial, right? 1 minus, that's 1, e to the negative 5, right? So it's pretty small, right?
What is it?
These crossed out, so to speak, right? Not bad? Pretty good? I think we did the whole sheet earlier, right? Ooh, look at that answer.
Mr. Murmer?
That's me.
Could you do number 7? Because I got 0 for both answers.
Sorry.
Oh, hold on, and I'll try to do my earnest.
Why
You're
is
good.
it 1 minus?
Because it said what? At least 1 hit?
Oh, at least, so you have to get the.
If I said exactly 1 hit, then P equals 1, okay?
So then it would just be whatever,
Yeah.
it wouldn't be 1 minus E, it would be just E, whatever.
Yeah. How about if it was 3? 0, 1, 2, right? Or whatever, right? Subtracting all that, and it's the rest of the screen. Okay?
Wait.
To me, that's the hardest part. Yes?
So we wouldn't be doing binomial. We would do that.
You could do binomial if you're here, but it's a lot easier, isn't it?
Okay, so you can.
Binomial, you got to put more stuff in there, and then you got to find the success and the failure rate. Right? You got to find then P, then Q, and
so
then you got
if
to
it
choose.
said, greater than or equal to 3, so you do.
If greater than or equal to 3, what would you do?
That x is
1
equal
minus.
to, or
If it said this, she asked this question. Good question.
Greater than or equal to 3.
1 minus. I'm going to do it this way. Is that okay?
Yeah.
P of what?
X equals 0.
X equals 0. Now notice what I'm doing. Okay.
Wait,
1
X is greater than 3?
2.
greater or equal to 3. At least
So
3.
you get 1, 2, 3, and 3.
1, 2.
and then do 1 minus all of that.
Okay.
Take it off. Right. Take it off the top.
Yeah.
And we
Okay.
have to do 3 too, right? Because it's equal to 3?
Yes.
Or no?
No,
No,
because it's
Yeah,
because of the
we're
1.
finding out less.
Yes. Okay. Yes, sir.
So,
You
yeah,
wanted
so-
me to do number 7.
Yes, that one is pretty astronomical.
Pretty monstrous. Is that the which one? I can't remember.
It's about the marriages.
Oh, that one? Oh, that's not a bad one. Didn't I do that one?
Ryan.
Didn't I tell you not to get married?
Ryan.
Didn't I tell you not?
I got like these
I feel like
astronomical
I'm one of those
numbers.
uncles. Like, yes, you were right. All right, so here we go. Ryan was on it, of course, right? How much time we got left?
We got some time.
5? All right, I better hurry. Okay, approximately N is 80,000, right?
Yeah.
Boom. Okay, and then it gives us what? We got to figure out 2 people that were born on April 30th, right? So that's the probability of the B day for April 30th, right?
So isn't it 365?
1 out of
What's the chance
365.
of you having the same birthday as me?
Isn't it 1 out of 365 times 1 out of 365?
Right.
And then times 1 out of 80,000, right?
Correct.
But then it's like this astronomical number.
Not 1 out of 80,000, right? This is the survey of 80,000 people, right? We're all
Oh,
80,000
okay.
people. Correct. Outstanding. High speed, low drag. So he did NP. He said lambda equals NP, right? Equals 80,000 times 1 over 365's quantity squared, right? And to save some time, 7.51 times 10 to the minus 6.
Does that mean there's 7?
That's the chance of you and me having the same birthday in a room out of 80,000 people. And getting married. Yeah. Yes.
And then the other one, they celebrated their birthday on the
Oh,
same.
I'm not finished yet.
Oh,
yeah,
oh,
yeah,
yeah,
you gotta
yeah.
let me get to this one, right?
Yeah.
So, here we go. It says not exactly 1, it's what?
At least once.
At least once.
Times 0 and then subtract
1
0.
minus 0.
1 minus P of 0, right?
Yep.
Do we need to do the rest, or are you okay? Oh, I'll do the rest. 1 minus, okay. All right, so let's see if I did this right here, okay? Oh, NP, I didn't do NP, right?
We didn't calculate it.
Oh, I didn't do NP, did I?
Yeah, you did.
Yeah, this comes out to, this is to the minus whatever, okay? And then times 80,000.
Wait, we already multiplied it.
I didn't. I did this one
So
first.
that's a small number.
Yeah, and this is 0.6.
There we go.
There we go. I just didn't do it right.
Wait, what is it?
I just did this squared, okay?
Alright.
And now times 80,000 is around
Say,
0.6.
There's a lot better chance of making 80,000 people.
Yes, exactly. You're going to increase the thing, right? So here we go, right? E to the what? Negative 0.6. Negative 0.6, 0.6 to the what? 0 over 0 factorial. 0.4512.
So what's the x equal to then? Oh,
Is this the final answer?
Yes, pretty good chance, right?
wait, how do you get?
It's 80,000 people, right? It's a lot of people.
Yeah, that's the.
Okay, go ahead. I'm sorry, say that
How
again.
do you get the,
Yeah.
0 again, I'm sorry?
Because it said what? What? Greater than 1 or something?
At least 1.
At least once. At least once.
So it could be more.
Could be more. 2, 3, 5, 10,000, whatever, right? Considers all those possibilities. That's A. Then there's B. Yeah. Both partners. This one, the probability was a little different here, right? So you're right. It's going to be 1 over 365, right? And then 1 over 365. And this is why I wouldn't include this portion of it. times what? How many days in the year? 365. Why would I do such a thing? Because I can.
Or,
Because it's just the same birthday, right?
Yeah, what's the possibility that I could celebrate it on any day of the year?
Any day of the year, because it's right. Times 365, right? This crosses out with this, so I get 1 over 365. All right? That's the probability for the same birthday. Then I just go lambda equals 80,000. Guess what? Times 1 over 365. And I get 219 and change.
And lambda is just the mean, right?
Correct. Now I just plug that in there for p is greater than 1. 1 minus p of 0. And you will get 1. Round 1. Pretty good chance.
Wait, how come we don't have to multiply that one by 80,000?
Because it's the same birthday.
To celebrate it on the same day.
Same day. Same birth, yeah. Weird, I know.
It's not that they're getting married with 80,000 people, it's just...
You're walking around and boom, right? So, yeah, this one was...
You're getting
This is
married.
okay, but this one... Yes, sir.
And then from there we have lambda, and then the
Yeah, you go what? 1 minus what?
1 minus the
E
probability.
to this monster,
Yeah.
and then what? 219 to the 0 over 0 factorial. And it comes out to approximately 1, because this is so small, right? Such a small decimule.
And then we just get it.
Now we find the probability that both partners celebrated their birthday on the same day of the year, but not just on April 30th, right? Computation is similar, however, we note that we can choose from one of the 365 days of the year for both partners. Mine will not be that airy. But I do like some of them in there, you know, Sammy selected, right? There's 3 of them. And I'm like, right off the bat. That's what you're going to see really in college. I know it's not Cambridge, but you see those, and then that's why I included 2 Cambridges. Okay?
Mm-hmm.
I like to give you, some people, just love Cambridge and so on. I can see where they're going